Hi everyone. In today's video, we're gonna see how to fine tune GPT 3.5 model. So let's see what are the benefits of fine tuning the model. First of all, we're gonna get the better or the higher quality results compared to the just prompting. We can also train on more example because what happens sometimes, your use case has many scenarios and you can't explain or put all those scenarios inside the prompt, and you need other way to actually give those examples to models. So I would say the fine tuning is the way where you could give many such examples and scenarios that you can't put inside the prompt. The other thing is that when you fine tune the model, you don't need to have a long prompt explaining again and again what exactly you want to achieve. You just give an example and model will produce the expected output. So you save tokens because the prompt becomes shorter, and the lower latency request because the longer the prompt, it's going to take more time to get your response from the OpenAI. But if you have the shorter prompt, you're going to get the quick response from the OpenAI. And since it has many advantage, it's good to actually see whether you could fine tune your own GPT 3.5 model. And even it is as per the OpenAI that if you fine tune the model, that fine tune model actually can perform as better as the GPT 4 model. So you can read actually more about this here. I think they have blog post, and they have detailed guide also. So we're gonna see step by step how we can fine tune GPT 3.5. So for the fine tuning, I generated dataset using ChatGPT itself. So I asked ChatGPT to give me some dataset. So it was failing to generate dataset in one go. So I wanted 100 example at least, but then it generated into the part. So I just combined that all dataset into the single file. So we're gonna use. I will explain you what exactly the dataset what we have. So maybe I think, yeah, this is the data set, the bank support training data set, which is nothing but we have some support queries, and then we have two categories or the topic, or let's say topic of that particular support query. So this is related to the fees and charges, and I also have the subcategory of it, so that this is more of like they used to decide where to forward your query. So this is like intent detection or the topic detection for the query. So we have around 100 examples what I generated with the chat gpt with the many categories and the subcategories, right? For example, you might say these are some of the examples, right? I haven't gone much into to how correct and all of these things, but let's say we have those 100 examples with us, right? And let's see what we need to do. So first of all, definitely we're going to require the OpenAI. So let's install the OpenAI library. And again, we have already seen the file, we don't need to read it. But again, if you just want to see again, read it as a pandas, and you can see we have three columns. One is the support query, which is our input, and then the expected output is the top category and the subcategory both identification. One of the challenging thing here, because we have only 100 examples and we have top categories which are unique, I guess we have 10 categories, and subcategories unique, I think we have many, more than 25 or maybe 30 categories what we have, the sub category here. The thing is that we know that in a classification, if you have a more categories or the more unique categories, you require more training example, because you want your data set should have at least significant representation for the each category. In our case, we have at least, or I guess we have exactly 10 examples for each category what we have here. But it is going to be very challenging for the subcategory, because subcategory we have hardly 2 to 3 examples for one category. So we're gonna see with the 100 examples whether GPT is able to identify both top category also and the subcategory also. That's we're gonna see. So first of all, if you look at the fine tuning guide what we have here, we could see the kind of data set that we need to prepare. So first of all, this is a chat model. So we need to make sure our training data represents some kind of a conversation, right? So it's going to be the set of messages that we're gonna send to the training, where you could have something like you can have a system message, you can have a, let's say, user message, and then you will have the expected output, which is nothing but the assistant message. So we want to make sure we're gonna format our data set in the same fashion. So in our case, what will happen, you know our input is going to be this support query, and then so this support query will go as, let's say, the user message inside the message, and the output is going to be an assistant message. I will show you the code, right? One interesting thing I want to do is actually, instead of outputting the plain these categories like this category colon or semicolon or something like this, I would rather want to output my this category as a JSON, so that it becomes easy to process in the downstream task. And that is also one of the advantage of fine tuning, that you can fine tune the model so that it can produce the JSON output and something, right, which is more reliable compared to the plain output. That's what we're going to see, whether the 100 examples are sufficient or not, right? So let's look at the code what I have done here. So we're going to read the file, and we know that we're going to iterate through each row of our data frame. This is each row of our data frame. And then what we're going to do, we're going to first require this part, because we want to convert these two columns into the JSON format what we want, right? So I simply to create the JSON string here, right? Let me close this part here. Yeah, so the top category is become one key in the JSON, and we take whatever the value inside that row. Similarly for the subcategory we get. And then finally we create our messaging array, where the first message is a user message, which is nothing but the actual support query, and the expected output is nothing but the assistant message, which is actually our JSON response, that what it should say. So we are actually teaching GPT that if user says this, or let's say user send this message, we want assistant to produce such a JSON having the category and subcategory of that particular user query. This is how we're gonna generate our training data. So let me run this thing so that we could see what exactly we generate. Now you could see when I run our training data, and I'm just printing our first message here, and you could see the first thing we have the role user, and user is asking, can you explain the monthly maintenance fee of my account? And then assistant gonna produce this JSON saying that the top category is fees and charges, and the subcategory is actually understanding fees. Okay, this is what let's say the training data set what we have created, and we want to make sure the output is really a proper JSON. So what I'm gonna do, actually I'm gonna read this particular value and load it as a JSON to make sure it is proper JSON. Okay, because since I'm able to get the Python dictionary using the JSON loads, seems to be this is a proper JSON. Now once we have the data set formatted in a particular format what ChatGPT requires, let's do one thing. Let's create two sets. One is the training, the other is the validation. So I'm gonna put 80% for the training and the 20%. So we will get around 80 examples in the training, and we want to make sure it is stratified so that the ratio of the that as per the top category at least we want to maintain. So let's create the training and the testing set. I would say training and validation. Actually, testing I have another separate. So I have another 20 queries that I kept it separately, which is going to be used for the testing. So for just training and validation, we have 100 examples. Okay. Now once we got the training data and the validation data, like 80/20, we know that we need to convert the data. Let's go back to the again, the example format and see what we need to do. So once we have that data, we need to convert actually into the JSON L, which is actually JSON a new line kind of a JSON lines format. It means you have each example on the each line. That's what we need to convert. So let's go back to our code, and we're gonna read our this training data and the validation data, which is nothing but, if you look at what is our training data, I think training data is nothing but just the list of this dictionary, this messages dictionary what we have it, right? Maybe if you want to print it again and see what exactly we have in the training data, we can do that thing again. Let's look at the training data, and you see it is nothing but just because training data is the list, and we have dictionary inside that particular. So each element in the list is the what were one example what we have, and we want to make sure that this needs to be written as a JSON lines format, where each of these go on the new line of the JSON file. So that's we're gonna do. So we have created this function write to JSON-L, which is nothing but taking our list, right? Then we gonna open some file. We're gonna iterate through our list for each entry. We're gonna simply use JSON dump, so which is nothing but we know that this is actually a Python dictionary. If you want to see, you can check its type. It's a dictionary, right? So that's why we are using json.dump, so that we get actually the json string, because we require the json new line file, right? So we're going to iterate through each of this dictionary, we're going to dump that dictionary into this particular file, but we're going to also write a slash n after that, so that each entry goes on a new line, and that's nothing but that json n file. So let me run this thing so that we get two files, one for the and we can see actually those files. Let's see. So we got a train. You can see now each object is actually on each separate line what we got. That's what it actually mean, the JSON L, this file format, right? Okay, now we got the files. Now we should upload those files to OpenAI, because that's the steps that we need to take. If you look, go back to again the the guide. It says that first of all, prepare and upload your training data. So let's upload our training data. To upload our training data, first of all, let's create the OpenAI object. Let's call it client. This is like new syntax coming after OpenAI, I think 1 point something. And here you can specify the API key. Ideally you should give it as an environment variable, but just for the tutorial purpose I'm like showing this key, but I'm gonna definitely delete this key once the tutorial is end. So now I got the client, right? And then what we could do, we can upload the file. So we can use the client.files.create. So we are actually creating file, or let's say uploading file. So we're gonna simply read our file, training file here, and then we can specify the purpose of the fine tuning, right? If you have seen my let's say earlier tutorial that I just created recently, which is OpenAI assistant, there also we have uploaded the file, but there the purpose of the upload file was actually assistant. If you seen that video, we can see the purpose was assistant there, but here the purpose is fine tuning, because we are sending it for the fine tuning purpose. So we read the training file, we read the validation file, and we're gonna no worry, we don't need to remember this code. It is actually available here, and you're gonna also get this notebook, as I always share my code. So you don't need to worry about, you can simply go and run this particular thing. So if you see, once we uploaded this file, in the response we get the file object, and we can look at its ID, because we're gonna require this ID when we're gonna submit our fine tuning job. So we got this training file ID, we got this validation file ID, right? Now let's create our fine tuning job. We're going to give some suffix to our fine tuning. Since I'm doing for the YouTube, I might do the YouTube, and maybe I said the YouTube tutorial or something like that, to give the, so that if I have multiple models, I can easily find that model which is related to, let's say, YouTube. Similarly, we created the files. We're going to create the fine tuning jobs. So client.finetuningJobs.create. We specify our training file ID, validation file ID, and which model we want to fine tune. Currently, it is available only for GPT 3.5 Turbo. So we're going to use this thing, and we're going to pass this suffix, so that this will be an extra, a name attached to the model, so that you can identify why did you, train that particular model, right? So let's submit our job. And once we submit our fine tuning job, we should get the fine tuning job ID. So we got some new ID here, fine tuning, this got created. And if you look at the moment, there is no fine tune model trained for this particular thing, right? It is not finished yet. You could see the number of epochs, it's gonna choose automatically. Batch size also, it's gonna choose automatically, because we haven't given any those parameters. Everything, it's gonna be an auto, let it choose. And you could see what model it has choose. It has choose the GPT 3.5 Turbo, this particular model, right? And this is how this is the response you got, right? Now we need to keep checking this particular job ID, whether it got completed or not. If the job completes, we will get this value, fine tune model. Okay, but how do we know whether it is getting completed or not? First of all, you can even list all your fine tuning jobs. So you can use client.fine tuning, and you can this jobs.list, you can list the, let's say I'm going to list the 10 jobs, and you could see, we should see this one also there. Oh, no, this one, where it is, I wanted to search this thing. Okay, so you could see the one job we just submitted, we can see that job also here. Now it has choose the epochs as a 3, batch size it choose 1, multiplier it chooses something else, whatever, this particular model, right? And let's see whether it is what is its status. Do we see status here somewhere? Okay, the train tokens also unknown. There must be status or somewhere. Yeah, here is the status. So status was here validating files. Let's see what is status here now. Yeah, status is running. So actually our fine tuning, job is running there, right? It takes some time actually to complete this particular job, and you need to keep retrieve, right? You can also, once you have the job id, you can also retrieve one particular job. So right, so we have this job id I can copy, and we also have one function to retrieve a specific job id. So I can put that job id here, right? And I can see the response, and I can retrieve that particular job id, and you could see the same job ids that it is running. We can see our file names, the status is running, and all of these things, right? So we can wait till this particular things get close. But before this recording this tutorial, actually I also had run one more time, just before that, so that I get the ready model the moment I start recording. So if you look at, I have a maybe this was the just model submitted, but I also have the other model. Let me search the a suffix called yt. Maybe no underscore. Yeah, no, so many places, but I just want to see the yt there. Yep, here. So if you see, I have one job here which is actually completed, which I submitted before I recorded. So if you see, this is it's a job ID. Maybe I just copy that job ID so that we can easily see. Let me copy this job ID and paste that job ID here. Okay, so you could see I created just before the recording of this particular thing, and we also got the fine-tune model name here. So now we have the fine-tune model. If it is still running, you will not have anything as a fine-tune model name. If you see the job we are currently running, it has a fine-tune model name none, but I got the fine-tune model name here. This is it actually says that it is a fine tuning. Then you have GPT 3.5 turbo, which model. Then I think this is your organization name or your account name, and this is the suffix that I had given, and some random string that they generate, right, kind of a thing. And we want the fine tune model id so that we can do the prediction, because it is the model trained on the same data actually. So let me look at the, once we have the response for that particular job, we can actually print the fine tune model id, and so that you can read carefully here, right? This is the fine tune model that I trained before this thing. Let me see whether this finishes. I think it takes time, it won't finish. Still I would try to check whether it got finished or not. The first one, oh no, it's not finished. So let's use the one which I trained before recording, like. So let's use that model for the prediction, right? So let's test our fine-tuned model that we have trained. So to test, we also want to make sure we again format our training data set in a similar testing data set in a similar way. So whatever the user query we have, we need to make sure we pass it as a chat message. So we will pass a role user and the actual query, support query we have, and we want to make sure it produces the role assistant in the response, right? So this is just simply formatting my row of our data frame, right? And then I wrote small function which simply does the prediction, which take our message, it will take this message, and it will take our fine tune model id, and we simply call our chat completion api. So we call our chat completion api saying that, hey, here is the model, and here instead of giving that GPT 3.5 turbo default model, I'm going to give our fine tune model id. This is the messages that I want, and some default parameter like temperature and the max tokens and all of these things, right? And eventually I will get the response back. Pretty simple stuff if you have used GPT prediction before recording, right? And then I wrote some function which actually gonna utilize or both the function formatting the thing and the prediction, right? Let's see what's happening here. Let's read our test queries. You can see the test queries are also similar. We have the support query and the top category, subcategory that we want to identify, right? Let's go and what we're going to do, we're going to read our test data frame, and eventually we're going to call our function called store predictions and see what's happening here. It is taking our training testing data frame, and it is also taking our fine-tuned model id, the one which we want to do the predictions, right? Then it creates one column called prediction and set all the values as a none, Then we're going to iterate through our testing data frame. Then we want to make sure each row what we are getting, we are formatting for the test, which is nothing but converting into the role, user, and the content support query. Once we got that test message, we are calling that same predict function that we just saw, which taking our message and the model ID that we want to do the prediction. And finally, we got the prediction result. And we want to make sure we put that result inside this column value. So we update our index and we actually look at the prediction column and put the value so that we can compare side by side, right? This is what this function does. So let's run the predictions. So we're gonna run prediction for those, 20. I guess we have only 20 examples. Let's see. Once it does the predictions, we should be able to see the predictions.csv file. Okay, it took 18 seconds for 20 predictions, which is pretty good. Which is pretty good. I would say 1 or 2 seconds for one example. That's quite fast. If you use the normal GPT call, it takes like a couple of seconds, right, for this. So let's look at the predictions. Now we will see how good the prediction, because we know the problem with our training data set, right? It had only 100 examples, and let's see which categories it is able to identify, which it is failing to identify. Let me do this thing now. Let's see. So the first question, it was related to account management and account maintenance. What it is saying? So it failed. It says customer service and the contact information. So it totally failed. Second, it is says account management. We could actually programmatically check this thing, but I just want to see side by side. Account maintenance, account management, subcategory account closure. Okay, so here we could observe it is able to identify the top category, but the subcategory it failed. We know that it's hard to identify subcategory because there are hardly 2 3 examples only for one subcategory, but at least the top category here it identified. What about here? Transaction service, the transaction inquiry, transaction service, here again it failed. So you see, top category it is able to identify because each top category we have 10 examples. Subcategory it failed. Transaction services, here also transaction services, transaction disputes it is saying, but it is actually failed. These subcategories are actually also overlapping, maybe. But one thing I could see, the top category it is able to identify, and again it is giving me a proper JSON. What about this card service, stolen card? Oh, this is correct, I guess. Card services, stolen card. Here again it failed. What about this online mobile banking and technical support? Yeah, this is correct. Online banking, security and access. This is also correct. Loans and mortgages, loan application. This is correct. Correct. What about the others? Saving investments, account types, saving investment option. This is wrong. Okay, so one thing we can observe actually, with the 100 example, it has pretty good performance because we know that it's hard actually, because we had just 100 example and there are top 10 categories, and then we have almost 25 to 30 sub categories what we have. It's really hard, right? I'm sure instead of these 100 examples, if we have a 200 or 500 examples where we have a sufficient representation of the each category, then definitely we should see the better results, at least for the categories where it is failing. So this is how you can train, and usually you should do the same way. You should start with the small data set, just 100 examples, train the model and see how good it is, and then you can collect more data. Let's say the next I could actually train it on a 200 example and see what happens, right? So when you are working on something on your problem, you need to start with the small data set and then see whether you have a sufficient data or you actually require the more data to train the thing, right? I hope you found this video useful. As I said, I'm gonna attach this notebook when I'm gonna upload the video there, right? So you have all these things. If you find a lot of things overwhelming, perfectly fine, you can go and check. I think you should have all the code here somewhere. Yeah, you could see all the things are here. I just try to explain those things. Thank you very much. If you want to give any suggestions, you can put it in the comments and let me know if any video that you are expecting from me. Thank you.